So we are going to see the very basics of triangles. What are triangles? They are three-sided geometric shapes. We are going to see how to compute their perimeters, their areas, and let's add also that they're three-sided geometric two-dimensional shapes. As well. And let's add a simple picture of a triangle. Most of the material I will be using comes from Wikipedia, illustrations and other visual material. And this, what you see here, will also be committed to GitHub. You will see a link to my GitHub account and to this repo at the explanation of this video. Here we go. Let's see what that gives. Here is a simple triangle, a blue one that is. Now, how do we compute the perimeter of this triangle? Basically, we have a function called compute perimeter. It takes differences of side AB. Let's assume that the corners of the triangle is called A, B, and C. My compute perimeter function takes an argument of diff side AB, diff side BC, and diff side CA. Basically, if this is A, this is B, and this is C, AC would be this side, BC would be this side, and CA would be this side. Let's annotate these types, these arguments a little, to make it more clear what we are trying to do. Diff side AB is simply either a float or an integer. Let's consider it a float. This is also a float. And what does it return? It's going to return us a float. Compute perimeter of a triangle. Wow. Let's change the name to simple compute. So I simply have to add all of the arguments to side BC to obtain what I want, CA. This is probably the simplest way you can compute the perimeter of a triangle. What about other ways? How can you compute the perimeter of a triangle using other means? We have one other way of computing the perimeter of the triangle. If we know the angle of the angle that is at the point A. So if we know the difference between point A and point B, and the difference between point A and point C, and the angle between two sides at the corner of point A, we can also compute the perimeter of the triangle. Let's say this function would be called angle compute perimeter. What do I need for this function? It's side AB, again a float, diff side CA, again a float, and theta, which is going to be a float as well. It's going to give me a float as a response. Compute perimeter of a triangle using two sides and an angle. It is crucial that the theta corner is at the corner A. So the unknown side is the BC side here. I know the AB side, CA side, but I don't know the BC side. What is good is that I know the angle that's right at the opposite of this side. Why is it good? Because from the law of sines, let's import math, we know that let's enlarge the stock string to include a little bit of mathematics, not very complex stuff. Well, let's see what was the name, what was the law that's going to help us here. It's the law of sines. Law of sines, which states that A over sin A is equal to B over sin B is equal to C over sin C. After a bunch of computations, after a bunch of let's say computations, after a couple of steps, we can also come up with the law of cosine, which can be formulated as c square is equal to a square plus b square a square plus b square minus 2 AB cos theta. AB cos theta. Now these are law of sines and cosines. This is all good and well, but what is A, what is B, what is C, how does it correspond to our case, and all that? Well, here our unknown side corresponds to the C square in the formula, and our known sides are A and B. So let's start by taking the squares of A and B. Diff side AB square, basically diff side AB times itself, up diff side square is diff side. I'm trying to use variable names that speaks. Normally I would just write A, B or something like that. I'm using the prefix diff because in a 2D setting, in an XY plane, this point is going to have two values associated to it. This point, this corner would have two values associated to it, and you would have to compute the distance between this point and this point. So I'm prefixing diff in order to remind to the reader or to the maintainer or to myself that these values just don't just come up. They're supposed to be produced at the end of a process. So let's also compute the 2AB. AB2, this is diff side AB times diff side CA times 2, of course, and let's compute the cos theta, which would be cos theta math cos theta math. I think the function was the function's name was math cosine or cos. Let's see what the documentation says is to use cos. So math cos theta at corner A. Now we are ready to rock, and rocking would not take too much time, but still C square is then diff side AB square plus diff side CA square minus AB2 times cos theta. Now what we obtain is the square value, so we need to take the square root of this, and we do it using the math function, the math module again. It's the function squared diff side, let's say BC would be math squared c squared, and the parameter would be the addition of all the sides again, AB plus CA plus this side BC. And this will be how you compute the parameter of the triangle using the angles, the angle and the two sides. Is this the only way? The Wikipedia gives us a lot of choices to use during the computation of the parameter of the triangles. I'm not going to go over every single one of them, but for the parameter of triangles, this should be more than enough for most of the use cases out there. The area of the triangle is a little bit more complex, but the simplest formula is the BH times 1/2 BH is basically the length of the base of the triangle times the height of the triangle, that is the distance between the base and the opposing corner, times the 1/2 times 1/2. Let's write a program to compute that, as usual. So let's call it def simple area triangle, def simple compute triangle, or compute area. Since the file is named triangle, probably we would assume that it computes triangles, the area of triangles at least, hopefully. So let's put the arguments out there without for now considering how are we going to actually obtain these values. So base length, height, and that's about the only two unknowns, only two knowns we have. We are going to compute, and with these two we can compute the area of the triangle. Let's say they are floats. Compute area of the triangle given base given parameters, let's say, and the solution is 0.5 times base length times height, length times height. Can we use other means to compute the same value? Yes, we can. For example, we can use again the trigonometric functions. In this case, we would need to know the two sides, again two sides, and an angle, and the angle we need to know is the incident angle between two sides. So basically we are trading off here the height with the angle, and the side associated to the angle. So let's see how we how we compute that, as usual. Again, Trigo compute area. So what we need to know is, again, the baseline, base length, and the incident angle, and the adjacent side. So let's say incident angle, flow, and the adjacent side. So the adjacent side is the adjacent side of the incident angle. So the incident angle is between the baseline and the base side and the adjacent side, basically. Compute area of triangle using Trigonometric properties. It's more or less the same formula. We just now, instead of using the height, we use the sin of the angle. So again, base length times the adjacent side times sin incident angle. These are basically the translations of the formula that are shown in Wikipedia to little computer programs, hoping that it might be used by you, or you might simply wonder how to compute with standard library. How do you compute all these geometric properties belonging to these objects? This is going to be all for now. We can also add some properties, some functions for checking for several properties that are associated to the definition of triangle. For example, can we make from these numbers, from these three numbers, can we assume that we can construct a triangle, for example? Let's just do one of those and finish this up. Possible triangle with from sides, so side 1, side 2, side 3. What do we know? We know that for a triangle to be possible, that is, if we want to draw a triangle, if we want to assume a triangle, there are certain criteria that we need to assume. One of them involves a simple of them, one of the simpler ones involves the size of the triangle. Basically, given three sides of the triangle, sum of any two sides of the triangle should be greater or equal to the third side. So check if arguments can make a triangle. So simply put, we are going to simply write side 1 2, side 1 plus side 2, side 1 3, side 1 plus side 3, and side 3 2 is side 2 plus side 3. And from here we're going to simply check if a side is bigger than these numbers. We can even include the checks here. Side 3, side 2, side 1. And if side 1 2 and side 1 3 and side 2 3 return true, if not, false. Let's check if this function holds. Let's give some numbers like possible 1, 2, and 5. Normally this should not work because the 5 is bigger than the sum of 1 and 2. Oh, we receive false. And let's see what we have if we do this one 4, for example, and it's true. So we can increase these check functions as well to see if we can do triangles from any given triplets. This might help you out in computer graphics. This might help you out in areas where you're searching for triangles, in point spaces where you're searching for triangles, if triangle is significant for your case, for example. So this is going to be all for this video. Thank you for watching. QM was here. Happy coding, happy mathing, not mathing in the sense drugs, but happy dealing with mathematics. Yes, that was all.